Hello, and welcome back to Shiksa DaCosta. Welcome to our final video on using analytic geometry to verify geometric properties. Here we're going to review the unit. In this unit, you learned how to verify geometric properties of triangles and of quadrilaterals using techniques from analytic geometry. We started off by exploring the connections between midpoints, right bisectors, and other important lines and points of polygons, and we noticed that when we start to do this, some interesting patterns start to emerge. And some of the ones that we looked at so far in this unit, to start off with, we noticed that the concurrency point of the right bisectors of a triangle is the center of a circle that intersects all three vertices, and we call that the circumcenter. So if we have a triangle here, if I plot points at the midpoints and draw a line right through that is perpendicular to that side, that's a right bisector. And if I do that for all three sides, I notice that these three right bisectors all intersect at a very specific point. That is the concurrency point. And that point is the center of a circle, just like that. And that circle intersects all three vertices of this triangle. We also noticed throughout this unit that the mid-segments of any quadrilateral can be joined to form a parallelogram. So here is a random quadrilateral, and if I plot points at each of the four midpoints of the sides, and then I connect those with lines, these are called mid-segments, and notice that they actually did form a parallelogram. Next up, the medians of a triangle. So a median, remember, is when you go from one vertex of a triangle to the midpoint of the other side. That line is the median. We notice that that perfectly bisects the area of the triangle. In other words, if this was made of cardboard, you can even balance that piece of cardboard on the edge of a ruler. Half the weight will be on one side and half will be on the other. As well, you might have noticed that the centroid of a triangle can be found by drawing all of the medians of a triangle. So there's that one, and there's that one. And the centroid of a triangle is the concurrency point of the three medians. And we can actually balance the entire triangle on the tip of a pencil exactly at that point because the triangle is evenly weighed in every direction. You also might have noticed that the diagonals of a parallelogram bisect each other. So going from one corner to the other, that's a diagonal. And these two lines cut each other exactly in half. We didn't quite verify this one to be true, but it's definitely something I'm going to leave as an exercise to the viewer. Another thing that you might want to look into is the pattern that the line segment joining the midpoints of the non-parallel sides of a trapezoid. So these two sides are parallel. If I draw a line segment joining the other two sides, this is actually parallel to the other two, to the parallel sides, and its length is the mean, the average between the other two sides. And I can actually show you a diagram of that happening right here. So this line segment right here is the average. Notice that it's halfway between the line here that describes the end of one line segment, and the other on the other side, this distance right here is also half of this distance over here. And so this is the line that joins the midpoints of the non-parallel sides of the trapezoid, and it is exactly the average of the other two parallel sides. Moving on to circles, we notice that the right bisector of a chord actually passes through the center of a circle. So if I draw that circle using a compass nice and perfectly, you might even notice that the center where the compass was is sort of indented. And you can put any 2 points on the edge of that circle, connect them with a line, and that's a chord. And if we draw the right bisector of that line by finding the midpoint and drawing a line that cuts that perpendicularly exactly in half, you might notice that that actually does go through the center of the circle. These are all patterns that we may have noticed, but we also learned how to verify them. To verify a geometric property, you can plot the vertices or any known points of the geometric figure on a coordinate plane, and then use algebraic techniques to verify that any side lengths are equal, or maybe two angles are equal, since we can use algebra to calculate exact values. Finally, we brought this to bear on the real world. We were able to use analytic geometry to solve problems from real life. And some tips I have for you in that regard are: first, definitely read the problem so you understand it really well, what it's asking you and what it's giving you. Create a diagram, transferring any known measurements from the problem right onto the diagram. And if you have to introduce any variables, please make sure to define them, including what unit you're measuring them in. Once you're done understanding the problem, make a plan to get from your known quantities all the way to your answer, and write down your plan and then carry it out. While you're doing that, make sure your work is really, really well organized. Make sure you're avoiding rounding any numbers until the very, very last step. That way your final answer will be as accurate as possible. If you end up calculating any new measurements, make sure to add that to your diagram, and then just make sure to see if it actually makes sense, that whatever you found as or calculated as a measurement actually makes sense in terms of the rest of your diagram. Finally, add a final statement that summarizes all of the things that you learned by solving that problem, and now is the chance you'll have to actually round any values appropriately. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.